On July 9, 2026, at 0217 hours local time, the Gazprom Neftechim Salavat Petrochemical complex in Bashkortostan was permanently changed. This facility supplied an estimated 22% of Russia's aviation kerosene production, fuel feeding the aircraft striking Ukrainian cities, along with critical polymer feedstocks and fuel additives flowing directly into Ministry of Defense supply contracts. The Russian security director believed Salavat was untouchable. He had no idea Ukraine had been watching it for 11 weeks. In exactly 4 hours and 19 minutes, that certainty would burn. 14 Bober-pattern long-range strike drones launched from concealed forward operating positions in eastern Ukraine at 21:58 hours on July 8th, climbing to cruise altitude under a moonless sky and immediately dropping their transponder signatures. They were already heading towards Salavat, on 400 kilometers to the northeast, before Russian radar stations in the Orenburg region had registered anything anomalous. The attack package flew in 2 staggered waves: 8 primary strike airframes carrying warheads, 3 electronic warfare variants designed to saturate regional air defense radar, and 3 optical reconnaissance drones trailing the formation to conduct real-time battle damage assessment. Speed: approximately 180 kilometers per hour at cruise. Altitude: between 50 and 120 meters above terrain. Terrain following profiles engaged for the entire Ural crossing phase. The drones approached Salavat from the southwest, the precise angular corridor that Russian planners had assessed as lowest risk, because Orenburg region air defenses had been repositioned northward following fuel infrastructure strikes on that city 6 weeks earlier. What's most surprising about this operation isn't the distance, it's the geometry. Ukraine didn't fly a straight line. Planners routed the package through 3 separate radar shadow corridors created by the Ural foothills, exploiting terrain masking that reduced effective radar coverage to less than 40 kilometers along the final approach axis. By the time any Russian operator had a clean radar picture of an inbound contact, the drones were already minutes from Salavat's outer industrial perimeter. The Gazprom Neftechim Salavat complex is not a generic oil refinery. Understanding what it actually does is essential to understanding why Ukraine targeted it in July 2026 and why its destruction sends a signal that reaches well beyond the Ural region. Built during the Soviet era and substantially modernized through the 2000s, Salavat operates as a fully integrated petrochemical node. It doesn't simply refine crude oil into fuel products. It processes those products further into chemical feedstocks, polymer precursors, and specialty compounds that feed downstream industrial chains across Russia's entire eastern industrial belt. The complex includes a primary atmospheric distillation unit capable of processing approximately 9 million tons of crude per year, a hydrocracker that upgrades heavy vacuum gas oil into high-value light products including jet fuel and diesel, a catalytic reformer producing the high-octane blending components used in aviation gasoline, and a dedicated ammonia and urea production train feeding Russia's agricultural sector across Bashkortostan and neighboring oblasts. For Russian military logistics, Salavat mattered for one specific reason: aviation kerosene. The complex was one of a small number of Russian facilities certified to produce TS1 grade aviation turbine fuel to the specifications required by both Russian military aviation and civilian carriers. Approximately 30% of the TS1 consumed by Russian Airspace Forces aircraft operating from Ural and Volga region airbases was flowing, directly or through regional fuel distribution hubs, from Salavat, or from pipeline infrastructure connected to it. Lose Salavat, and you don't just lose a refinery. You start starving airfields that Russian planners considered geographically immune from the war. Analysts tracking Russian defense industrial capacity have estimated the replacement value of the Salavat hydrocracking and aviation kerosene production infrastructure at approximately $2.1 billion. And that figure doesn't account for stored intermediate products, catalyst inventories, or the specialized heat exchangers and reactor vessels that carry lead times of 18 months to 3 years under normal procurement conditions. Under sanctions, those lead times become effectively indefinite. Here's the part that doesn't make sense on the surface. Salavat had been on Ukrainian targeting lists since at least late 2024, according to open-source analysts tracking Ukrainian drone campaign priorities. Why wait until July 2026? The answer tells you something important about how Ukraine's deep strike campaign has matured. Early Bober pattern operations prioritized targets within 800 to 1,000 kilometers. The 1,400-kilometer threshold required not just sufficient drone range, the Bober airframe was already theoretically capable, but a full intelligence preparation of the target environment, mapping of Russian radar coverage gaps, validation of terrain masking routes through the Urals, and the development of a multi-layer attack package that could suppress or saturate local air defenses without relying on standoff jamming aircraft Ukraine doesn't operate. That preparation took time. By July 2026, it was complete. Put yourself in the position of a Russian air defense operator at the Orenburg Regional Radar Station at Orl 30 hours on July 9th. Your sector has been on heightened alert since the Orenburg fuel strike 6 weeks earlier. But that alert has also meant your attention, and the physical repositioning of mobile pantsir and TOR systems has been oriented south and southwest toward the corridors those strikes came from. Nobody told you to look northeast. Nobody told you the Ural foothills themselves were about to become the attack approach. The Bober, in Ukrainian Bober, doesn't get as much public attention as the Shahed series or the earlier UJ-22 airwave. That relative obscurity is partly intentional and partly a function of how Ukraine has managed information about its most capable deep strike systems. What is known, drawn from confirmed strike evidence, Ukrainian government statements, and open-source technical analysis, paints a picture of a purpose-built long-range loitering munition that represents a significant leap beyond Ukraine's earlier fixed-wing kamikaze platforms. The Bober is a fixed-wing turbofan-powered drone. Crucially, it uses a turbofan engine rather than the piston or small turboprop power plants found on earlier Ukrainian strike drones. This matters for 3 reasons. First, turbofan propulsion at the relevant thrust class is significantly quieter at cruise than comparable piston engine platforms, reducing acoustic detection range particularly at low altitude. Second, turbofan fuel efficiency allows the Bober to achieve operational ranges exceeding 1,400 kilometers with meaningful warhead payloads, which piston engine competitors cannot replicate at equivalent size. Third, turbofan-powered flight at low altitude produces a smaller and less distinctive radar cross-section than the comparatively larger airframes required to achieve similar range with less efficient propulsion. Payload capacity for the primary strike variant is assessed at between 50 and 100 kilograms of high explosive, sufficient to cause catastrophic damage to refinery process equipment, particularly the pressure vessels, heat exchangers, and reactor internals that are both critical and irreplaceable on short timescales. The warhead design used against the Salavat complex appears to have prioritized penetration before detonation, what military engineers call a delay fuse configuration, allowing the warhead to pass through the thin steel shell of process vessels before detonating inside, maximizing internal damage and dramatically increasing the probability of secondary explosions from contained process hydrocarbons. Navigation on the Bober relies on a combination of GPS, GLONASS-independent inertial navigation, and optical terrain correlation, the last of which is specifically designed to maintain positional accuracy even when Russian electronic warfare systems attempt GPS jamming or spoofing. Ukraine learned from painful early experience that GPS-reliant drones over Russian territory face aggressive jamming environments. The Bober's navigation package reflects that learning. I spent considerable time going through the open-source technical reconstruction of this strike, and one detail kept pulling at my attention: the 3 electronic warfare variants in the attack package. These weren't carrying warheads. They were carrying jamming payloads. And their job wasn't to destroy anything. Their job was to create a window. A window in which Russian radar operators trying to build a coherent picture of what was inbound found their screens showing noise, ghosts, and contradictions long enough for the 8 strike airframes to complete their terminal approach unmolested. That's sophisticated. That's not a country improvising drone attacks. That's a country executing a mature electronic warfare integrated long-range strike doctrine. The planning phase for the Salavat operation was grounded in an intelligence preparation effort that had been running, based on available evidence, Since at least March 2026, commercial satellite imagery from multiple providers, several of which supply data to open-source research organizations tracking the war, shows systematic monitoring of the Salavat complex at high revisit rates beginning in that period. Analysts were looking for a pattern. The facility's operational rhythms, its internal traffic, the positioning of the security perimeter, the location of primary versus backup process equipment, and, critically, the thermal signature patterns of the hydrocracker and the primary distillation unit, visible in infrared satellite passes that reveal which process trains are running hot and which are offline for maintenance. Route selection for the 2,400-kilometer approach required solving a genuine geometric puzzle. The Ural mountain range runs roughly north to south, and its western foothills create a series of natural radar shadow zones, areas where ground-based radar stations in the Orenburg region cannot see airborne contacts at low altitude because the terrain itself blocks the radar line of sight. Ukrainian mission planners, working from a combination of publicly available topographic data, electronic intelligence about Russian radar station positions collected over months of prior operations, and likely some signals intelligence support from partner nations, mapped a 3-segment approach route that kept the attack package in radar shadow for approximately 340 of the final 500 kilometers. The remaining 160 kilometers required the electronic warfare drones to carry the mission, jamming and saturating the coverage gaps that terrain couldn't mask. Launch timing, 21:58 hours on July 8th, placed the attack package over Russian territory during the period of maximum radar operator fatigue, arriving at the target in the 02:00 to 03:00 local window that military planners across every theater consistently identify as the lowest vigilance period in a 24-hour defense cycle. The window also coincided with a low-pressure weather system moving through the Ural region, which produced cloud cover at roughly 800 to 1,200 meters. High enough not to impede the low-altitude drones, but sufficient to complicate visual detection and make any Russian interceptor scramble more complicated in terms of visual identification protocols. Here's what Russian regional air defense planners had not adequately prepared for: the 3-dimensional deconfliction of the attack package. The strike drones, the electronic warfare drones, and the trailing reconnaissance platforms were flying staggered altitudes in coordinated formation. Not a single swarm but a layered package with each element optimized for its role. Russian Panzer S-1 systems, even when cued to engage, face a genuine prioritization problem when confronted with simultaneous contacts at different altitudes, different speeds, and different radar signatures. The Bober strike package was designed to exploit exactly that problem. At 02:04 hours, the lead element of the first wave crossed the outer security perimeter of the Salavat industrial zone at an altitude of approximately 35 meters, having descended from cruise altitude during the final 12 kilometers of approach. The electronic warfare drones, flying a racetrack pattern approximately 40 kilometers to the southwest, were at that moment producing jamming emissions across the frequency bands used by the Salavat facility's radar-assisted perimeter security systems and the nearest active Pantsir battery. Russian operators received fragmented, inconsistent radar returns, some real, some electronic artifacts, and the response was a critical 7-second delay in engagement authorization. In drone terminal attack timelines, 7 seconds is enough. The first impact occurred at 02:17 hours local time. The hydrocracker's high-pressure feed section. The warhead penetrated the primary reactor vessel casing and detonated inside, rupturing the internal catalyst bed structure and igniting the hydrogen-rich process stream under pressure. The result was not a simple explosion. It was a pressure-driven fireball that propagated through connected piping into the adjacent heat exchanger train, triggering a cascading failure of 3 interconnected pressure vessels within approximately 90 seconds of the initial impact. A second drone struck the primary atmospheric distillation unit's overhead condenser system 11 seconds later. A third impact hit the rail loading manifold at the facility's eastern edge, the infrastructure used to load refined product into tank wagons for movement east toward the Trans-Siberian mainline. The fire was visible from the city of Salavat, population approximately 140,000, and from highway monitoring cameras on the approach roads to the industrial zone. Independent monitoring accounts documented a thermal plume that persisted for 9 hours and 17 minutes before being brought under partial control, with full extinguishment not achieved until the following evening. One detail that stuck with me in reviewing the damage assessment: the rail-loading manifold strike. It wasn't the most spectacular impact. It didn't produce the largest fireball, but in targeting terms, it may have been the most strategically considered. Even if the refinery itself could be partially restarted within weeks, an optimistic timeline given the damage to the hydrocracker. Without the rail-loading infrastructure, finished product cannot move. You can refine oil at reduced capacity and have nowhere to send it. The strike didn't just damage production, it severed the logistics link that makes production economically meaningful. Russian official communications in the immediate aftermath followed a now predictable pattern. Regional authorities in Bashkortostan initially described an industrial accident under investigation. Within 6 hours, after satellite imagery and social media documentation from Salavat residents had made denial untenable, the framing shifted to acknowledgement of a Ukrainian drone strike accompanied by claims that air defense forces had intercepted the majority of the attacking drones, a formulation that leaves the inconvenient question of how the facility is burning unaddressed. Bashkortostan's governor announced emergency measures, including a temporary closure of airspace over the Salavat industrial zone and surrounding area. And within 48 hours, regional fuel distribution authorities had announced rationing at 3 petroleum product depots serving the local market, a direct consequence of disrupted product output. Western technical analysts examining available satellite imagery of the post-strike facility assessed physical damage to the hydrocracker and distillation unit as severe, likely requiring complete replacement of the primary reactor vessel and extensive reconstruction of the heat exchanger train. Estimated repair timeline under pre-war procurement conditions: 12 to 18 months. Under current sanctions conditions, with the Russian petrochemical equipment manufacturing sector already strained from prior strikes on other facilities, the timeline becomes genuinely unclear. The estimated financial damage to Russian industrial infrastructure from the Salavat strike is assessed at between $1.8 and $2.4 billion, a range that reflects uncertainty about the extent of secondary damage to catalyst inventories and downstream processing equipment that cannot be assessed from imagery alone. Here's what most analysis leaves unsaid. The Salavat strike represents a fundamental change in the geographic logic of this war. From the beginning of the full-scale invasion, Russian military and civilian planners operated on an assumption that was entirely reasonable given Ukraine's capabilities in February 2022. That the Volga-Ural industrial belt was simply beyond reach. Too far. Too deep. The distances involved exceeded anything in Ukraine's arsenal. That assumption shaped investment decisions, facility security protocols, the positioning of air defense assets, and the psychological baseline of an entire regional population that had watched the war on television rather than from their windows. The Salavat strike erases that assumption. It cannot be restored. Once Ukraine has demonstrated the ability to reach a target at 1,400 kilometers with a coordinated multi-platform attack package, Russian planners must treat every significant industrial facility east to the Urals and beyond as a potential target. And the air defense resources required to meaningfully protect all of them do not exist. Will Russia find a way to reconstitute its Ural region air defense coverage against this threat vector? Comment yes or no, because the answer shapes everything that comes next in this campaign. What this tells us about the broader trajectory of the war is worth sitting with. Ukraine's drone campaign began as a tactical nuisance, FPV drones harassing frontline armor, early UJ-22 strikes on fuel depots within a few hundred kilometers. It has evolved, systematically and deliberately, into a strategic instrument capable of reaching deep into the Russian interior and striking targets that directly degrade Russian military capacity over months and years, not just in the immediate battle space. The pace of that evolution has consistently outrun Russian countermeasure development. Each time Russia adapts its air defense posture in response to one attack profile, Ukraine has developed the next one. The Salavat operation is not an endpoint. It is a data point in an accelerating curve. Russia will almost certainly respond with increased air defense asset deployment to the Ural region, at the cost of thinning coverage elsewhere. It will accelerate attempts to harden remaining petrochemical facilities with physical barriers and close-in defense systems. It will increase electronic warfare emission density in corridors identified as likely approach routes. None of these responses are without cost, and all of them consume resources that Russia is simultaneously being asked to apply to the active front lines. Every major industrial facility east of the Volga is now doing a calculation it never had to do before July 9, 2026. Ukraine's long-range drone corps has not just extended its reach, it has redrawn the map of what this war can touch and what Russia must now defend. The Ural Mountains were never a wall. On July 9th, Ukraine proved it.